In this video, we're going to take a look at factoring special polynomials. In your book, this coincides with chapter 4.6 called Special Factoring. And the polynomials we're looking to factor are going to be ones of the kind that are trinomial squares, perfect square trinomials, the difference of squares, and certain polynomials. We're going to factor by grouping, which we've practiced already before. And then we're going to take a look at the sums and differences of cubes. So let's take a look at A. So what is a perfect square trinomial? A perfect square trinomial takes the general form of a number squared plus 2 times your first term and your second term plus the second term squared. So the first term squared, 2 times the second and the first term multiplied, and the second term squared. Now, to factor that, we could go about our business as usual by creating the what do you call these? Our little guy here, and doing. I need factors of y squared of 1y squared. That'll give me 2 xy's, right? And we know that there's 1y here and 1y there. So y times y is y squared, and that'll give me 2 y's. So what ends up happening is when I factor this out, it'll be x plus y times x plus y, or simply x plus y quantity squared. And this is what I mean when I say taking the first term, squaring it, double the two terms, and then taking the last term, square it. So if I were to crab claw this guy out, right? Crab claw. Then my first two terms would be x squared. My second term would be plus xy, and then I'd have another plus xy here, the second part of the crab claw, and then the last term would be y squared. Notice that these two terms here are exactly the same. It's just my x times my y, and then I double it. So the general form of a perfect square trinomial is x squared plus twice the two terms plus y squared. Let's take a look at one example. Let's say we had x squared plus, I don't know, 8x plus 16. And I want to factor that as a perfect square or binomial square. Well, recognizing that 16 is a perfect square and that 8 is twice the square root of 16, the square root of 16 is 4. That's how I get 16. 4 times 4 is 16. So, and this is 2 times 4 here. So that's how I know that my last term will be a positive 4, and then my x squared is just x. And I take that whole thing and I square it, and now we're factored. Let's try another one. Let's say I had x squared minus 10x plus 25. Well, I noticed that this is 5 squared, and this is 2 times 5. So basically, all I have is x 5. Now this is a minus here, so it's going to have to be a negative 5. So it's x minus 5 quantity squared. It's really that simple. That's factoring the difference. I'm sorry, a perfect square trinomial. Taking a look at factoring the difference of squares. The difference of squares is when I have a square number and I'm subtracting a square number. And this is a little bit like a perfect square trinomial. Let's practice. Well, I'll show you what it looks like first, and then we'll practice it. So what I have here is x plus y times x minus y. Let's see how that works. If I were to multiply this out, let's crab claw again. We'll crab claw in red this time. Crab claw. As far as the terms go, that would be x squared. Now, x times y, a negative y, is a negative xy. And this y times this x is a positive xy. And now I have a positive y times a negative y. Gives me a negative y squared. And again, if you take a look here, I have my middle terms are opposites. They cancel each other out. So I'm left with just the x squared minus the y squared. So whenever you see the difference of two numbers and they're squared, say something along the lines of y squared minus 49, you could say, oh, well, 49 is 7 squared, right? 7 squared is 49, and y squared is 2, y times y. So that should be y minus 7 times y plus 7, right? Really, it's quite that simple. Let's try one more just for fun. If I have x squared minus 36, well, then I have square root of x squared is x. Square root of 36 is negative 6, and x plus 6. That easy. You should be able to recognize them and do them, even in your head. Okay, let's try. So we've done factoring a square, trinomial square. We've done factoring the difference of squares. Certain polynomials, by terms of 4 terms, by grouping, and we've kind of seen that already. Let's try one that says x cubed plus 3x squared minus 4x minus 12. And we've done factoring by grouping. I can take this group here and factor it, and then I can take this group here and factor that separately, and then see if they have any common factors that we'll be able to remove. That's funny. All right, so let's try that. Let's do this one too. What do these two terms have in common? What can I divide out of both of those terms? Well, they both have an x up to the second power, so they both have an x squared. And if I divide out an x squared there and an x squared there, I'll be left with, here I'll be left with just 1x, because 3 minus 2 is 1. These actually cancel to 1, so that'll be x plus 3. All right. Well, let's do my other two terms here and ask ourselves, well, what can we divide out of that? Well, they're both negative, so let's divide out a negative. And they're both divisible by 4. 4 is the greatest common factor. So when I divide out a negative 4 from both of these, I will get those cancel to 1. I get x, and those cancel to 3, so plus 3. And now I ask myself, do my two terms have a common factor? And in fact, they do. They have this. This one has an x plus 3 and an x plus 3. So I have x plus 3. I can divide that out from this term and from this term. And I'm left with x squared minus 4. Okay, well, cool, but lest we think we're done, what do I have here? See, this factor is prime, this one is not. This can be factored further. So it is the difference of two squares. So I know my x plus 3 is there, but the difference of two squares is the root minus the root times the root plus the root. And now we're factored as far as we can go there. Now the sums and differences of cube numbers don't actually take that much to do. this is the general form. If I have a cubed plus b cubed, or if I have a cubed minus b cubed, we use the SOAP method. And the SOAP method is quite simply that I take the cube roots and I use the same sign first. So that S stands for same. And then I take the number squared, and then I take the multiple of those two numbers, and then the last number I'll take that squared. And the O stands for, so if this is the same, the O stands for opposite, and the AB stands for always positive. And that's how to do the sum of squares. Let's try the difference of squares. So that's A, B, and then A squared, AB, B squared. And let's apply SOAP like it needs it. Let's apply SOAP to the difference of cubes. So if we're doing factoring the difference of cubes, I use the same sign, so that one is a minus. I use the opposite sign for the next term, and the last one is always positive. So that's factoring in a nutshell. Some of our special factors. We've done trinomial squares, we've done difference of squares, we've used grouping already in the past, and I just showed you today how to factor the sums and differences of cubes.